Hi, everyone, and welcome to Astro at Home, presented by Discover the Universe. This week is our final week doing Astro at Home, and today we had originally scheduled Amanda Green, who's a STEM teacher in Alberta, to speak to us about robotics. Unfortunately, we had to make a last-minute change, so we have a different speaker today, and before I introduce him to you or reintroduce him to you, I just want to remind you about some of the ground rules for using our chat. So I think most of you guys have been here before and you know the rules, but in case you're new, we ask that you stay respectful of one another and that you not spam the chat, which is just sending several messages one after the other that fills up the whole chat screen. If you break those rules, we'll delete your message or we'll put you in a timeout, which means you won't be able to answer or ask rather questions for 5 minutes, which would be sad because we want your questions. So today we are joined by Jesse Rogerson, who was with us last week talking about Astro News and the Super Earth and the black hole thing that I don't remember what it was called. But he's back today to talk to us about the SpaceX launch that's happening tomorrow, I believe. And I'm already seeing people are really excited about him being back. So, oh, Jesse. Giving away the goods, playing a video.
Sorry,
so,
my bad.
It's okay. So, Jesse, we're just kind of going with the flow today. And so if Jesse's presentation is a little short, then we'll just go into a Q&A and you guys can ask him questions about just about anything. So without further ado, I'll let Jesse join us and take over and we'll get into it.
Okay, thank you, Lindsay. Hi, everyone. Everybody can see me. Everybody can hear me, I think.
Yep,
yes.
We're good.
Okay, we're good. Okay, good. So I just want to, there we go. Okay, so thanks for that introduction. I wanted to, I posted in the YouTube chat room that it was me again. And the people are like, it's you again. I thought it was your last one. I don't know what's going on. And I'm glad that I see some people are pretty excited to have me back. So I'm excited about that. I like chatting about space. I work at the Canada Aviation and Space Museum in Canada, in Ottawa, Canada, the capital of Canada. But I have no idea where everybody else is from. Like, where are all of you from? Where do you come from? Tell me in the YouTube chat room there, in the chat to the box to the side. Just tell me. Maybe you're Canadian. Maybe you're elsewhere in the world. It'd be cool to know where everybody's coming from. That's the beauty about doing this on YouTube or doing this on any kind of online platform, is that we can talk with anybody from around the world about space, and that's what I do. That's I'm a scientist, but primarily I'm an educator. I work at a museum, and my job is to communicate science, to build exhibitions, to do programming, teach about, like, for instance, we have a planetarium show that we created. We have a little comet making demo that we created. Oh, there's someone from India. That's awesome. That's so far away. That's super cool. Rome, Italy. Oh my gosh. Someone from Rome, Italy. Wow. Everybody's all over the world. I hope everybody's staying safe and happy and calm during all these crazy times. Oh, lots of people from Canada. Oh, we got someone from Halifax in Canada. Cool. Wow. You're from all over the place, everybody. That's super cool. Now, as Lindsay said, I'm a little bit of a substitute teacher today, so I might have a short presentation, but I really want to emphasize that we should really make this like a Q&A of any possible thing that you wanted to know about space. Any question you've ever had about space, today's a good day to ask them. I do have one little thing to talk about that'll get us going, and I'm going to start playing a little video right here. Because this is a big deal. This is a big news event that's happening Wednesday, so 2 days from now, is the launch of the Crew Dragon capsule by SpaceX from Florida. So this video you're watching right here is an animated video, a graphic representation of what's going to go down on starting on Wednesday. So SpaceX is a private space company. It's famous for being owned by Elon Musk. And SpaceX has been working with NASA to develop its space capabilities for a very long time. They started launching years ago, like a decade ago, I think, or more. And it's all kind of been leading to this. What you're looking at there on screen is it's a capsule designed to take humans to space. This is something SpaceX has not done before. They've never launched humans before. They've only ever launched robotic spacecrafts. And but one of the things they've been attempting to do through NASA's commercial crew program is to create a human-rated spacecraft. Now, they did one test of it last year while Davis Saint-Jacques was up there up in space. But this Wednesday will be the first launch to have any humans on board. There'll be 2 humans on board to test out the SpaceX capsule. It's going to rendezvous with the International Space Station, and it'll be a robotic autonomous docking with the space station. And this is a graphic representation of what that will look like. It'll dock there on the node right there. The cool thing about this also is that the two humans that are going up, they're NASA astronauts, but they're wearing these fancy new spacesuits that SpaceX developed. They're going to be up there for an undetermined amount of time. They haven't determined exactly how long they're going to stay on board the ISS, but it could be anywhere from a couple of weeks to a few months, depending on the type of things they do while they're up there. And then it will disembark from the ISS. It'll make some space, get away from it a little bit. The front nose will detach, and that front part will spin around and bring them back to Earth. And that part you see heating up will be pointed forward. We do aero braking to slow ourselves down. That's how we get back onto Earth. We use the atmosphere to slow ourselves down. And then once we're in a free fall, the parachutes come out and will bring the humans back down to a relatively soft landing in the Atlantic Ocean off the coast of Florida. So all of this to say that there's going to be a human launch coming from Florida on Wednesday. Now, why is that important? Why am I talking about this? Because we all know that humans have launched from Florida many, many times. But the important thing to note here is that this is the first time that humans have launched from the United States since this launch of Atlantis on July 8th, 2011. That's 9 years ago. Now, the reason for this is because the ability that the shuttles that they were using that NASA was using to get people up and back from the International Space Station, they did a very great job. They were working for like 30 years. They did over 100 missions, but the space shuttle was getting to the end of its lifetime as a technology. It wasn't safe anymore. They didn't want to push its lifetime, and so the shuttle program was canceled. They had the last launch was in 2011, and therefore the only other way to get to the International Space Station between 2011 and now was the Soyuz spacecraft. So this is a picture of the Soyuz spacecraft that launches from Kazakhstan, and it's launched by Roscosmos, the Russian space agency. And this is actually an image from when Davis Saint-Jacques went up back in December 2018, I think is what it was. And so that one right there, which holds 3 people on board, was the only way to get any. And it's done a really great job. It's been launching lots and lots of people up. Canadians got to go up. Davis Saint-Jacques went up on a Soyuz, and lots of other people have done that as well. But it's always very important for other countries to have that capability to fly to the International Space Station. And so the launching of this, here's a great image of the Crew Dragon. So there's the Crew capsule right there, and it's being set. This is an image from just a little bit while ago. Does the spaceship have a name? There's a good question. Does the spaceship have a name? It's the Dragon Crew capsule, or the Crew Dragon capsule. So many of you may have heard of the SpaceX Dragon capsule that sits on top of the Falcon 9 rocket, and that was an autonomous. It had no humans on board, and it was used by SpaceX many times to get cargo up to the ISS. This is the Crew Dragon capsule. So it's a Dragon capsule that's been specifically created to take humans as opposed to cargo. Yeah, there you go. So this is an image of the Crew capsule there getting ready to launch. And these are the two astronauts and their fancy spacesuits that are going to launch on Wednesday. And you can see that the spacesuits are slightly different than the ones you've seen that NASA built. That's because these ones were made by SpaceX. They weren't made by NASA. These two astronauts are NASA astronauts that have been training with SpaceX to get prepared for this launch. And this is a great shot right there. See there, you can see the Dragon crew capsule. There's the logo of the capsule right there, getting ready to go. And here is, I just wanted to say one more thing before we go. Okay, just moving. Okay, so here's a flight plan. And this is the super cool thing about SpaceX. That is not something that any other space company is doing right now, or even any of the government. So you can see from the launch right here, there's an ascent. So this is where you're burning your rocket fuel, you're flying, and then you have your first stage is detached and your second stage goes. The second stage right here keeps going up towards the ISS, and it follows this dotted line here. But this first stage, this spent rocket stage that has no longer any fuel in it, SpaceX has specifically designed the Falcon rocket and that first stage to be reused. And so what happens is this part right here, this first stage, which no longer has any fuel in it, does a little flip maneuver, points, it has a little fuel left for landing, points its rocket in the opposite direction, turns on its retro rocket, and goes in for a landing. And it actually can land either on a boat out in the middle of the Atlantic, or they have even tested them coming back right to Florida and landing on dry land, so that they can reuse this rocket stage again, which is really great. As opposed to just using it once and discarding it, SpaceX is attempting to be able to reuse all of their rockets over and over and over again. It brings the cost way, way down. And of course, as that's going in for a landing, the two astronauts on board are going to keep going up and ready to rendezvous with the ISS. It'll take about somewhere within a 24-hour period for them to rendezvous with the ISS. And in that period, in that time, they're going to be doing a whole bunch of checks of the system, because this is the first time that this capsule has flown with humans in it. It's never been flown with a human before. So they need to test everything from detachments of the Dragon separation right here, getting on the right trajectory. They need to check all the systems. They need to do everything that has to be done to ensure that it's ready to dock with the ISS. And here's a great picture of it, a nice animated image of it. And we got there's lots of questions coming in. When is the next rocket gonna fly? That is on Wednesday, with two humans on board, two astronauts from NASA. What do they do at the ISS? That is a great question. What do they do at the International Space Station? And what is the International Space Station? So the ISS stands for International Space Station. It is a partnership of 5 space agencies and many more countries. So it's United States and Russia, which were the prime, the major countries involved, but Canada, Europe, the European Space Agency, and the Japanese Space Agency we're all partners, and we all send astronauts to the ISS. It's a space station that's the size of a football field, and on board the International Space Station, scientists are able to do experiments. They're able to study things. One of the most important things that we study on the International Space Station is human biology. So how do humans react to living in space? What effects does the weightlessness of space have on humans? And how does that help us moving forward if we wanted to go further into space? Say we wanted to go to Mars, or we wanted to go to Jupiter, or we wanted to send humans all the way to the edge of the solar system and back. Those are big questions, and those would take years, if not longer, to go for a human. So how would you send a human into deep, deep space and make sure they stay healthy and safe while they do it? And that's one of the most important things that the International Space Station is doing. But it also has a huge range of research that it does. Everything from, they're studying ultrasound equipment. They're studying material engineering, how to build certain kinds of materials. They study plant biology, which is really interesting. How would you grow plants in space? They study psychology of the astronauts that go up. They study space. On board the International Space Station, there's a telescope that measures cosmic rays. So it's not an optical telescope that you use with your eyes, but a big, huge one that measures high impact particles coming from deep space. So there is a lot of research going on. In fact, if you Google right now, if you go to Google and you say International Space Station research, there's a whole website dedicated to the active experiments that are going on. And you can even filter it by your country. So you can be like, what are all the Canadian experiments? What are all the Indian experiments? What are all the American experiments? There's some really great stuff going on there. And you can even find the people who are doing it, because they might even be local to you. There could be a researcher in Halifax that is part of an experiment aboard the International Space Station. There could be a researcher, there's some here in Ottawa where I live, that there's a researcher here in Ottawa at a university that sent an experiment to the International Space Station. And you could even email them and talk to them and ask them questions about what they're doing. It's a lot of great stuff going on. Okay. Do I have any more slides? Oh yeah, so I'll get to your questions, but I just wanted to point out, this is a picture from inside a Crew Dragon capsule. So this is a Crew Dragon capsule. This was from the first test flight back last year. It had no humans in it. It was an empty test flight. And what you're looking at right here, this is a mannequin. There's no human inside that. It was just put in there to show the spacesuit. But these two humans were already on board the ISS, and the Crew Dragon test came up and met the ISS, and then the humans on board the ISS went in to take a look. And I believe, if I'm not mistaken, I believe that right there is David Saint-Jacques, the Canadian astronaut who was there last year. So the automated test went up, docked with the ISS, and the astronauts on board the ISS went in and checked out the systems. It was a crucial part of getting to where we are now, which is testing it with humans. So the whole point of all of this, and I'll go back one slide. The whole point of this program is to get humans, another way for humans to get to the International Space Station. It will be launching from North American soil as opposed to from Kazakhstan. And what's also really important about this, and the real difference here, is that SpaceX is a private company. SpaceX is not a government-owned entity. All of the technology that SpaceX built, SpaceX owns. The opposite way of doing it is, in the past, say with the shuttle program or with the Apollo program, NASA would pay for it, NASA would oversee it, and NASA would own the technology. Now with this commercial crew program, with SpaceX testing this out on Wednesday, NASA gave the money for it. It was a NASA contract. NASA provided the stipulations of what needed to be done, but then SpaceX did the oversight, and SpaceX owns the technology. So that's a very different way of getting to space than we've ever done in human history. And it's what it represents is a new era of space exploration, where you have both governments and private industry working in tandem, working together to do different types of things. And this is really, really good for space exploration, because a private company like SpaceX can take it in their own direction, and a public entity like NASA or CSA can take it in a different direction. We can get more done, and we can have lots and lots of different kinds of research. Okay, I need to ask questions. Sorry, I need to answer questions. Okay. All right. Okay. Is rockets the only way to go to space? Yes. Virgin Galactic is working on a space plane type thing, but it still uses a rocket to get up there. What is the ISS? We got that. Will we ever be able to make something like X-Wings? No. I mean, you don't really need wings, right, in space. Wings are for lift, right? Wings create lift. So an X-Wing, and I have an X-Wing right here. That's so funny that someone mentioned it. So because I'm a geek, I have my own X-Wing. There you go. There's my X-Wing that I made out of Lego. My sister got this for me for Christmas. So an X-Wing, these things on Earth, when we have wings, we use the wings to create lift. I'm not 100% sure what these wings are needed for in space. So maybe to hold cool things on the end. I don't know, but that's what we already do. I would argue that we already do create cool things like X-Wings. They just don't look like X-Wings. They look like regular spaceships that we make. Is there a Chinese space agency? Great question. Yes, there is. There's the Chinese have a fantastic space program. They actually have their own they actually have their own space station. They have their own capabilities of launching humans to space and back. They have their own space station where they go and stay for long durations of time, and they do their own research. They are a very powerful space country, but they're not part of the International Space Station Agreement. So they're not part of that. And I'm not sure why they're not. There's a lot, it's probably very political, but hopefully one day, in the way that United States and Russia ended up partnering together, we'll be able to include the Chinese in what the ISS is doing, and many other countries. It's only the 5 major space agencies on the ISS right now, and the more space agencies we have included, the more we represent the world. So lots of countries are doing their own space stuff, and may or may not necessarily be attached to the ISS program. Have I been to space? I wish I went to space. I would definitely take the chance to if I could. What is my take on the multiverse? Well, the multiverse, okay, it might not be like what you're thinking. So we have what we call the observable universe. So we are bound by the physics of our universe to only see a certain distance, there's only a certain measurable size. And that's bound by the speed of light. So if you look out into space, the furthest thing away that we can see is about 13.8 billion light years away, because that's when the universe began. That's when our universe started expanding. And we have this distance that beyond that, light hasn't had enough time to get to our eyes. So the idea that there is more beyond our observable universe is very valid. There is probably more beyond what we can observe. We're bound by the physics of our universe to see only so far, but there is probably more. Now, if you want to call that a multiverse, I guess you might be able to. But the idea that there is a bigger universe beyond our observable universe is very sound. So I don't know if I would call that a multiverse. I would just say the universe is everything, and we can only see so far within it. Oh, where can we watch the liftoff, and what time is the liftoff, and how many days does it take to reach the moon? Great questions. Okay, it's Wednesday. It's 4:30 p.m. Eastern time, Eastern Daylight Time. So what I would suggest, it depends on where you are, Google the SpaceX Crew Dragon launch, and NASA will have a live feed, and we'll be able to tell you what time for you that works. So that's, NASA will live stream it, as will SpaceX. SpaceX on its website will live stream the launch. I would highly recommend watching, because it's the first time this has ever happened. How many days does it take to get to the moon? About 3 days at conventional rocket speeds. So we have a lot of history of going to the moon, not only the humans that went there back in the 1960s and 70s, but all of the robotic missions that we've sent there before the humans went in the 60s and 70s, and many after. If you're traveling at roughly 25,000 to 50,000 kilometers an hour, then you're going to be taking about 3 days to get to the to get to the moon. What do I think about the ISRO, the Indian Space Agency? They're fantastic. I remember recently, a few years ago, they launched an orbiter to the moon, an orbiter to Mars called the Mars. Oh my gosh, it was called MOM, the Mars. Oh, I can't remember what it stood for. MOM. India is doing incredibly great things, and they're being very successful at what they do. I don't know a lot about their program, but I know that they're being very successful at what they're working on. Okay, who is the next Canadian to go to space? Other than me? No, it won't be me. The next Canadian to go to space. Well, we have 4 active astronauts right now. So David Saint-Jacques, he just went to space, so it probably won't be him again. There's Jeremy Hansen. He was hired at the same time as Saint-Jacques. There is Dr. Jenny Sadi-Gibbons and Joshua Kutrick. Those 2 were hired recently, very, very recently. I think 2017 they were hired. So of the 4 that we have are active in Canada, the most likely one is probably Jeremy Hansen. He's the most senior who hasn't flown yet. But of the 4 that are there, I bet all 4 will fly again. Like Saint-Jacques will probably fly again, and the other 3 will definitely fly either to the International Space Station or to the Lunar Gateway. The Lunar Gateway mission is a proposed space station that will be orbiting the moon instead of orbiting Earth. And it's quite likely that Canadians will visit that in the next 10 to 15 years. So probably the next Canadian to go to space will be Jeremy Hansen, and then followed soon after by Sadie Gibbons and Kutrick. Oh, I love it. Okay, I need your support. I want to become an astronomer. Please suggest the tips to how to become an astronomer. Okay, how to become an astronomer. Well, for me, you can do it 2 ways. You can do it on your own time, or you can go to school for it. So I went to school for it. I went to university and I took physics and astronomy, which basically is a degree in physics. And you do a lot of astrophysics classes at the same time. And so it's just physics and space. And after I finished my undergraduate degree, I did a master's and a PhD studying astrophysics. So I didn't know much about astronomy until I got to university. I started when I was about 17, 18. I took an elective course in astrophysics and I really, really enjoyed it. And so I just dove into it. It really helped that in high school, I was really good at physics and I was pretty good at programming. Those 2, physics and programming, are really important. And I can't stress enough, math. Physics, math, and programming are all sort of overlap with each other in skill sets. And I would recommend working on that if you want to be in astronomy. I'm not saying I'm good at math. In fact, math was one of my worst subjects in high school, but I worked at it. I worked and I worked and I worked because I wanted to be an astronomer. So I just did it. I had to. I studied and I worked hard and I got help when I needed help. And when I did poorly, I studied harder. When I did well, I knew I was heading in the right direction. So you need, if you're in high school right now, work on your physics and your math. Make sure those are really strong as you can make them. And then I would look into opportunities to do a little bit of experimenting with telescopes. And the other way would be to do it completely on your own. You can buy your own telescope. You can have your own day job. Say you have a day job being like, I don't even know. You could be a car mechanic. And then you could also buy your own telescope and observe things for various citizen science projects around the world. Like there's some really great ones, like some of the best scientists I know do it just for fun. And they use their own telescopes, they study stars, and they watch the stars change their brightness. And they publish papers on that. It's really, really great. So you don't have to get a telescope. You don't need to buy one. You don't need to, in fact, I never had my own telescope growing up. When I got to university, I started taking physics and astronomy, and I worked really hard on my math and my physics. And now I ended up where I am. Okay. Is supersonic the same as the speed of light? No. Good question. The speed of light is how fast light moves. And then supersonic is talking about the speed of sound. So sound, it depends on the medium that it's in, but in our atmosphere, sound travels depending on where you, like at sea level, at regular temperatures, it moves at like 300 meters per second. And supersonic would be moving faster than that. So if you could fly faster than 300 meters per second, then you'd be moving supersonic. But the speed of sound is dependent. Like the speed of sound in Venus's atmosphere is very different than the speed of sound in Mars's atmosphere, which is very different than our speed of sound, because it depends on the makeup of the thing that the sound is going through. So supersonic is just saying moving faster than the speed of sound of the thing that you're in, whereas light speed is a very different thing. Okay. What would happen if your skin was shown in space? Oh, like say you had like a rip in your spacesuit and your skin was breathing or shown to the outer space. Well, that's a good question. So if you had a very small puncture, or it depends on a lot of things. It depends on how big the puncture is of your spacesuit. If you just like took your glove off, and if you're floating around in space and took your glove off, all the air in the spacesuit would rush out, and then you would asphyxiate. You would run out of breath, and you would choke, basically. Space is a really interesting place because it can be really hot or really cold, but depending on if you're in the sunlight or not in the sunlight. It depends on a lot of things. If you were in sunlight, then it would be really hot. It'd be you'd be feeling the radiation of the sun over 100 degrees Celsius. And if you're in the cold, it would be minus 150, but you wouldn't necessarily get frozen right away because there's nothing to take the heat away from your arm. If your arm was just sitting in a vacuum with no air, then your hot arm can't transfer heat to the air to pull the heat away from you. So you would have to radiate the heat away using your infrared, your body heat, which would happen, but it wouldn't happen instantaneously. That's a good question. How much does Jupiter weigh? Well, Jupiter doesn't weigh anything. It has mass though. Remember, mass and weight are different things. Jupiter, I don't know how much Jupiter has in mass. It's a lot. Okay, is it possible that somewhere in the universe, it is called the Mars Orbiter Mission. Yes, that was the one from the ISRO. Is it possible that somewhere in the universe, all of the fiction that we have made could exist on a planet? Maybe, but I wouldn't worry. Like, we're really imaginative, and we could imagine a lot of things. That doesn't necessarily mean they're going to exist within the framework of our physical universe. Some things like, is there life in other places? Probably. We don't know for sure, but we're working on it. Is there intelligent life in the universe? I don't know. We don't know really. Maybe there could be. We're working on finding that. But to have some idea where everything is much like our science fiction, probably not. It's probably not going to be like the way we imagine it to be. But the fact that there is life out there, and there might be interesting technology that we don't know about, maybe, but probably not like the way we see it. I'm 14. I selected for NASA's Space Settlement Contest. I'm feeling proud. I visited NASA, 12 years old, from India to LA. Wow. Oh my gosh. Good job. When I was 14, I feel like I wasn't even thinking about space. So good on you. You're heading in the right direction. Keep doing what you're doing. I want a telescope. I'm wondering what can I see with it? Oh, great question. Okay. Depends on how big your telescope is. So like we tend to think of the telescopes in terms of the diameter of the tube, okay, of the mirror. So you can have little ones that are like only 2 inches or 3 inches wide, the mirror, or you can have big ones that are like a foot wide or 30 centimeters or 50 centimeters wide, big, huge ones. And the wider the tube of the telescope, the wider the mirror, the fainter things you can see. So it depends on what you have. If you have like a typical one, like a starter telescope that's like 3 to 5 inches wide, that'd be really great for the moon. It'd be really great for planets. I would recommend trying to check out all of the planets, all of them. So Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, Ceres. Look into all of the major bodies of the solar system. Jupiter and Saturn are really amazing to look at. And Jupiter and Saturn right now are up early in the morning, so you'd have to get up early to see it. But with telescopes like that, you can look at you can look at the Pleiades star cluster. You can look at the Orion Nebula and the Orion constellation. There's so many great things. I would recommend, actually, there's a book by, oh my gosh, what's his name? I think it's Dickinson. His name, yeah, Terence Dickinson. So Terence, I think his book is called Night Watch. Yeah, okay. There's a book called Night Watch by Terence Dickinson. And it is a practical guide to viewing the universe. It's meant for people who want to learn how to look at things. And I would recommend checking that out. Wait, does that mean that you're always at supersonic speed in space because sound doesn't travel in space? So that's a fun way of thinking about it. There is no speed of sound in space. And so you can't be moving faster than the speed of sound because there is no speed of sound in space. The speed of sound in space is 0. it's non-measurable. So I guess technically you're always moving faster than the speed of sound because sound can't travel in space. What is the best university to study astronomy? Oh my gosh. Okay, what country are you from? Because that depends on a lot of things. But there's so many possible universities that you can go to. In Canada, we have some fantastic schools that you can study astronomy at. So there's, based on my own experience, you can go to McMaster University, has a fantastic astronomy department. University of Toronto, fantastic. York University, very good. Kingston, what's in Kingston? Queen's University, McGill, Université de Montréal. There is University of Calgary. There is UBC and University of Victoria. I'm missing some. What's out in the East Coast? Dalhousie has some good stuff. We have some fantastic schools in Canada, and the United States has just as many, if not more. There's oh my gosh, there's University of California. There's Ohio State University, really good. There's State College in Pennsylvania. There's a bunch in Florida. The UK has great ones. The Australians have really great ones. There's some really great ones in Chile. Astronomy is a very big science around the world, and most countries have everything that you need. So it depends on where you're from, but there's a lot of really good ones. I see Lindsay's here to stop me.
Yeah, you can finish your train of thought if you weren't finished, but you did list a bunch of universities.
Yeah, that's about it.
Do you have other questions that are coming in? And a lot of them are really interesting. But I know we don't really have time to get to them. So I added a link to your Twitter account in the description box. So if you guys have more questions for Jesse, it seems like you guys were just starting to get warmed up, because in the last 3-4 minutes, we've been getting a lot more questions, which is unfortunate because we're at the end of our time. But if you have a question that you just can't help yourself, you need an answer to it, you can go find Jesse on Twitter and send him a message there. I also added a link to the Night Watch book that he was just talking about in the description box below. So if you're interested in buying that, I sent you to amazon.ca, but if you prefer to buy your book somewhere else, you can do that too. So you can just find the name of the book and go to the place where you prefer to buy your books from and do that. So I'm still getting questions in the YouTube chat, but unfortunately we can't get to them today. But yeah, it was Jesse seeing there that he can take them on Twitter. So anyway, thanks so much, Jesse, for filling in last minute for us.
You're welcome. I can't believe how many questions everybody had. I feel like it was like I just sprinted a marathon or something. It was amazing.
You did great. Tomorrow, I'm not sure what we're doing because of today's shift. It's affecting tomorrow, so I can't entirely tell you. We're thinking maybe Amanda will be back, or not back, but she has been here before, but she was supposed to be today. She might happen tomorrow, and if not, then we have somebody else on standby, and we'll just see what happens. So tomorrow will be a bit of a surprise for you guys. And then just a reminder that on Friday, it's going to be our last Astro at Home, at least for a while. And then we're taking a very long break for the summer. And in the fall, we're going to figure out what's happening when school is supposed to start again. So we'll see what happens. But just a reminder, if you want to get your notification tomorrow, you have to subscribe to our channel and then click the notification bell. And if you enjoyed Jesse's presentation today, then give it a thumbs up. We would really appreciate that. All right, so I guess we will talk to you guys tomorrow at 2 o'clock Eastern time. Thanks so much for joining us today, guys. We'll see you later. Bye.
Bye, everyone.